In 1996, the Federal Reserve agreed to 9 changes in the design of all U.S. currency except the $1 bill. The most visible change was a new and larger portrait set off center. But turning the new designs into actual money was an enormous undertaking. It began in this attic studio at the Bureau of Engraving. Engraver Will Fleischl transfers a wax outline of the new Lincoln portrait onto a clean piece of 1/4-inch steel. Next, he'll begin to cut that design into the plate by hand. No cut can be deeper than the thickness of a human hair.
It's hard to even see the lines that I engrave without a 6-power to 10-power glass, and that's purposefully done.
The minute details make the portrait harder to copy accurately, but they also make the engraver's job harder.
You have to learn to control your breathing. You have to get used to looking under magnification for long periods of time.
Perhaps the biggest challenge facing the engraver is working in reverse.
Drawing in reverse is kind of a conundrum. I mean, you have to trick yourself all the time.
It can take up to 8 months to complete a single portrait.
I enjoy watching the image develop. This was a great man, but at the same time, he had a really raucous sense of humor. He was the kind of a guy that you could talk to. I try to convey that.
The use of portraits on the face of the currency is actually done for a security reason. People are used to looking at people's faces, and they can notice a lot of detail. They can notice differences, so that if someone else tries to reproduce that Ben Franklin and doesn't do quite as good a job, you'll notice that.
Another new security feature is much harder to notice. It's called microprinting. Some engraved letters are just 1/100th of an inch tall, much too small to be reproduced on a copier. All the letters are engraved by hand for 2 reasons.
Having a hand engraving rather than a computer-generated image gives us what we feel is not only the best image, but also a secure image. Even the same engraver couldn't reproduce that exact same hand-cut image if they tried again.
It's also for security reasons that no one single engraver ever does all the work. Changing the design of U.S. currency was only one part of the Federal Reserve's program to deter counterfeiting. The other part was changing the paper. 100 years, all U.S. currency paper has been made in Dalton, Massachusetts, at the mill owned by Crane and Company.
The message to Crane is we're interested in every conceivable new form of anti-counterfeit technology, but whatever you do, don't change the feel of the paper.
The feel of the paper comes in part from the raw materials that go into it. They're actually waste products, bits of cotton, flax, and denim.
It turns out that denim, ever since its invention by Levi Strauss, has been the cloth material that has the highest quality cotton.
Some aspects of paper making haven't changed in centuries. Bales of cotton rags are loaded into the top of a huge boiler. After the hatch has been locked down, a cleaning agent will be added and the cooking will start. The boiler is 14 feet wide and is suspended 8 feet above the ground. It's made of cast iron and holds 3.5 tons of rags. The temperature inside will rise to 280 degrees Fahrenheit. After 2.5 hours, the rags have been stripped of their natural oils. What emerges is raw cellulose. But even this is not strong enough to make good paper. The fibers must be made to interlock more tightly. To do that, the rags begin a violent journey. They're mixed with harsh chemicals beaten into The most unusual feature is this security strip, which took scientists at Crane more than 7 years to develop. It starts as a roll of plastic 2¼ miles long. The roll is cut into strips 1/16 of an inch wide. Embedded in each strip are letters, here magnified 75 times, that spell out a bill's denomination. Each letter is cut out of multiple layers of a special foil. The security strip will be inserted into the paper by a secret process. The strips have a unique property. They're not visible under reflected light, so they can't be photocopied. Only when light shines through the bill can one see the security strip.
It's very easy for the public to identify that and see whether or not it's in there. It's very hard for a counterfeiter to replicate that. If there is not a thin strip embedded in the paper of your bill, then you should be suspect of it.
For added security, the strips are dyed colors that glow under ultraviolet light. Green is for 20s. Another The wire mesh with the image is clamped into a special container. The pulp is similar to that used for currency paper. As the liquid drains out, the fibers settle onto the surface of the screen. Fibers collect most deeply in the dents of the portrait. The pulp is then lifted onto a piece of blotting paper. The portrait sticks up highest. The pulp is quickly dried under a weighted cover. What will emerge is a faint portrait that's actually part of the paper itself.
It's a series of steps that have been practiced by paper makers for many, many years. We have simply refined it. It's a process that Crane holds as one of our prized secrets.
In fact, the actual process of inserting currency watermarks is so secret that it's done behind guarded curtains. Watermarks are inserted every 6 inches onto the currency paper. This sheet with Andrew Jackson watermarks will make 20s. But the paper is not yet ready for printing. It must first get a chemical coat so that the ink will stick to it. The paper then travels through a series of 25 dryers at 300 degrees Fahrenheit. Next comes a rigorous inspection.
We have to confirm and verify that all of the things that are in the paper, whether it's a watermark, a security thread, are all present in the very specific location where they belong in the paper.
14 different cameras now scan the paper. The laser burns a tiny hole wherever there's a defect.
One defect in the unwinding of the security thread destroys the paper potentially all the way across the full width of the paper machine.
Each finished roll weighs 4 tons and is more than 58,000 feet long, enough for 3,200,000 banknotes. But the inspection isn't over yet. If the paper's too damp, it may rot. So they weigh sample pieces. If any of the samples contains more than 6% moisture by weight, the entire roll will be turned back into pulp. The paper's temperature must also be within a specified range. The paper's strength will be tested on these 125-year-old machines, which push and pull a 2-inch paper sample. If the sample tears before it's folded 8,000 times, the entire roll will be rejected. Every roll that passes inspection is cut down into smaller rolls, then fed into a high-speed cutting machine. Each sheet can make 32 banknotes. Even at this point, an inspector can reject an entire roll. The finished sheets are stacked into blocks of 20,000.
By the time we're done with it, we have invested a great deal of know-how in converting these materials of almost zero value into the most prized and arguably the most valuable paper in the world.
In fact, the paper is so valuable that every shipment leaves the mill under armed guard. The paper arrives here at the Bureau of Engraving and Printing in Washington. Today, they're getting ready to print new $5 bills. Each printing plate gets a final inspection. The plates are bolted onto the printing cylinders 4 at a time, enough to make 128 notes per revolution.
The Bureau produces, on average, about 38 million notes a day. That's pieces of paper, for a full face value of approximately $400 million a day.
To print that much money requires 3 tons of special ink a day. The exact formulas are kept secret, but black ink is used for the front of the bills and green for the back. Once the plates are inked, the paper can be added. The fronts and backs of all currency are printed separately. The fronts are always printed after the backs, so that the portrait will stand out clearly. It's critical that the paper be lined up properly. The press operator removes any sheets that have slipped out of position. Finally, they're ready to start making money. At full speed, the presses will churn out over 268,000 bills an hour.
The United States currency is printed by the intaglio printing method. So we actually emboss the paper, forcing the paper into the engraved lines. So you have that raised feel to the print.
Before printing is complete, the bills must pass an exhaustive inspection. The inspectors first make sure the sheets don't stick to each other. Electronic sensors will scan every note. They check the placement of the security thread and the watermark. A sheet is rejected if the space between the edge and the printing is greater than 1/10 of an inch. Other sensors check the density of the ink. The sheets are flipped twice to check both sides. But even machines can make mistakes, so a technician inspects samples to catch any errors that might have slipped through. Now the sheets will move on to the final and critical stage of becoming money. Each note will be given a serial number composed of letters and digits. The serial number is a banknote's birth certificate. The number is printed in green in 2 places on the front of every note. The letters indicate the Bank of the Federal Reserve that asked for the money. $100 at a time, they're sliced into sets of 2 notes, then into individual banknotes. Hundreds of hours of labor have turned scraps of fabric and a few drops of ink into the world's most valuable currency. The finished banknotes are bundled into stacks of 100, then bound into blocks of 1,000. Each block is shrink-wrapped and barcoded. The Federal Reserve will use the barcode to keep track of the amount of money that's printed. Manufacturing U.S. dollars is one of the most profitable businesses in the world. Every new banknote, from a $1 bill to a $100 bill, costs just the same, 4 cents.
We manufacture a product that it's always easy to explain to people what you do. When asked what you do, you say you make money, and people know exactly what you're talking about. No matter where I am in the world, people know our product, they use our product, and they'd like to have more of it.
All new banknotes are sent to Fed banks, such as the Federal Reserve of New York's Check and Cash Processing Center in New Jersey. The Fed monitors every shipment from arrival to departure.
It's our responsibility to keep track of every single piece of cash that comes in the door. So the inventory of money that's in the possession of the Federal Reserve is of critical importance.
Most of these new bills will replace worn-out notes. The remainder is new money ordered by the New York Fed.
It's entirely at the demand of the public. Whatever currency the public demands and wishes to buy from the Fed, we supply to it. And that expands and contracts.
The New York Fed has the special job of supplying currency not only to its regional banks, but to all foreign banks as well. Almost 2 million new banknotes arrived here in 1999. Each of these large crates can hold up to 300,000 notes worth as much as $30 million. To increase efficiency, the Fed began using guided robots in 1992. Each robot's path is programmed down to inches to reduce wasted movement. This robot is entering the most important room in the building. It's the largest cash vault in the world. It's 3 stories tall and almost the length of a football field, though the exact dimensions are kept secret. That's because at any one time, there's from 70 to $90 billion stored here. Around the clock, 4 automated cranes retrieve and deposit crates of cash. Some of the crates hold used bills, others hold newly printed ones. Remarkably, much of this money will end up outside the United States. In fact, 2/3 of all U.S. currency, $360 billion, is now held in foreign countries. This fact, along with the spread of digital copiers, has created an enormous problem.
The fact that the dollar is traveling into areas of the world that were not open to us 20 years ago, combined with the fact that people travel much more so than ever before, really makes the dollar a ripe target for transnational counterfeit activity.